Hello, my name is Ansgar Lemke and I want to tell you something about ROS. The basic definition of ROS is ROS, the robot operating system, is a flexible framework to write robot software. It's a collection of tools, libraries and conventions to simplify the building of complex software in robot area. But what does this mean? Who uses ROS? The robot operating system is important for universities as well as some companies. Science uses ROS to investigate new technologies in robot area. Some companies like PAL Robotics, PAL with their robot REEM, Neobotix with some mobile robots, or BMW use it to some extent. There are a lot of companies that use ROS in research projects. Car manufacturers use it to study autonomous driving cars. The garage itself created TurtleBot and the PR2 Robot. There is no completed list of all the projects that make use of the robot operating system. An open source project cannot count its users. Some companies appeared at a ROS conference one day to tell the world that they have been using ROS for years. As you can see, ROS is quite common in robot research area. You do not want to waste a lot of time at the immense setup required by any robotics project if you want to do a proof of concept. If it comes to commercial usage, ROS has some issues related to safety. Even now, most companies rely on homebrewed solutions here. Today, ROS is 13 years old. In the intermediate time, things have happened. The story began 2006 as PhD students had the vision to build a Linux for robotics, because robotics projects at that time were very difficult and time-consuming. You could say that 90% of a project's work were spent in that task. Actually, the work was quite similar in different projects. Due to lack of time and workforce, nobody did it well. A new version either had to use a software without documentation or write it new from scratch. Research projects in robotics area were very limited by this condition. Let's give you an example to illustrate the problem. You think of how it would be if there would be no operating system at all at your PC. You have to write all the programs directly into bytecode. Let's say I want to create a program to calculate the square root of some number x. Some days later, stuck at all the zeros and ones, I give up. I imagine to create some kind of graphical user interface. The thing I got working is to present the square root of 2 with a precision of 10 digits. Nice, but not very helpful. In such a world, trust me, no one would use any computer to do any computations. You would be faster to do it by hand. Maybe 100 computers on the whole planet would be enough for the remaining freaks. Does this problem sound any obvious to you? People laughed at the visionaries to Eric Berger and Kieman Willebeck from Stanford University because their plan was to build the ROS framework / operating system / middleware and 10 identical robots to promote it. And they wanted to make use of the greatest software engineers. They estimated the cost would be as high as $4 million. Finally, a first check of $50,000 came from Joanna Hoffman and Elaine Russman. They said, use that money and build as much as you can. They built the PR1 robot and some base documentation to collect more money. But there are people in the world with a huge amount of money. One of them is Gota-san. He's worked at Google and other projects. In November 2007, he invited them to his Willow garage. He also stopped the other projects he had ongoing, so they could concentrate on ROS only. He gave the motivated engineers and a lot of resources. In January 2010, ROS 1 was ready with a lot of documentation and components which are still in use. Another step towards the spread of ROS was an intern program that included actors from industry and institutions that helped to spread ROS usage and popularity. 2013, ROS moved to the Open Source Robotics Foundation. Other startups and organizations were being founded out of Roller Garage, which closed in 2014 finally. And Google bought some of them. Once per year there's a ROSCon meeting of developers, companies, organizations and institutions. They talk about their projects in ROS and establish new contacts. Now I want to give you some overview on the components of ROS. First, take a look at the 5 system concepts. They are packages. Packages contain nodes, libraries, datasets, config files, or other things. Each package has a package.xml file called the package manifest. Meta packages are collections of related packages. Repositories collect packages with a common version control system, like Git or Subversion. There are some file types to mention. Message types with the ending .msg describe messages or define the related data structures. Service types .srv do the same for services. If you execute your program, ROS builds the so-called computation graph. Usually, graphs consist of nodes and edges. Applied to ROS, there are some special terms. Let's start with the nodes. While running your program, they are treated like independent processes. Inside the nodes, the computation work is being done. Client libraries help that code in different languages can be used. At the moment, we can use both C++ and Python. Messages are one element of communication. Related to the definition in the corresponding file, they are treated as data structure. Messages can be sent via topics. Imagine topics as communication channels. Nodes can either subscribe to receive messages or publish to send messages to a topic, or both or none of this, as the developer wants to use it. This model of communication is anonymous. In some situations, a direct communication is required. Therefore, ROS now services. A service consists of a request and a reply. Both use the data types described in the related service file. This can be used if feedback is required. The master coordinates the chaos here. He plays DNS server to tell the nodes where to find the other and cares about the parameter server. The parameter server is a central place where data can be stored. Data should be static here. You can store dimensions of the room, of the robot which is working in, or in maybe some configuration of your program. A ROSback is a set of tools for recording from and playing back to ROS topics. If you think, oh, I could save messages by my own, consider that ROSback is optimized so it avoids deserialization and reserialization processes. As I already told, ROS is an open source project that means there is a community which helps to develop the software and test it and helps with bugs. They have repositories in GitHub to publish ROS and ROS related stuff and code and libraries and develop it. The ROS Wiki gives you a lot of information about how to use ROS, how to install it, what problems can be there. There's a question and answer site called ROS Answers, where you can find answers if you have some problems with installation or with some libraries, something doesn't compile. And of course, ROS has got a bug kicking system. If you want to get informed about the latest news, consider subscribing to mailing lists or read the discourse. One other concept is a distribution. A distribution is nothing more than a new version of ROS, a collection of versions, and it is published by ROS to be installed. Their alphabetic names are names of turtles. What's my personal contact with ROS? I for myself work in a project which uses ROS. It's T-Rex from ReSpace. Marvin Baral, how do you use ROS?
Here at T-Rex, we use ROS as our main framework. Why do we do this? Because it gives us a great thing, modularity. We can write our software in separate nodes and combine them to form different systems. One great example of this is how we do simulation. We have a bunch of nodes that are our core software. And then we have some hardware interface nodes like a camera node inputting images and a motor node outputting speeds. So when we run our simulator, we do not launch these hardware interface nodes. Instead, we launch a simulator node which attaches to the very same interfaces. So when we do simulation, our core software stays exactly the same as in the actual system. It is very easy to do such things just by switching the launch file.
Thanks a lot. Launch file contains information how, in which order to start up the nodes of your program. What about using academic software in industry? Could this work? There's some different disadvantages of ROS1. ROS1 has some trouble with real-time things. ROS does not fulfill security standards, which are of a big importance in industry. There are a lot of constraints. Initially, ROS was developed for the PR1 and the PR2 Robot. And after that, there was a rapid growth into other fields, such as autonomous driving or drones. So we built ROS2. There are a lot of features. ROS2 supports multi-robot systems. Supports multi-platforms, so not only Ubuntu, like ROS1, but also Windows, Mac, Linux, and even RTOS, real-time operating systems. It improves real-time performance. It anticipates non-ideal network conditions, which are quite common in a lot of environments. It can be used in production environments as well. There's better support of microcontrollers. There are a lot of big changes done in contrast to ROS1. They use the DDS transport protocol for their publish and subscribe model. So they entirely rewrote it, and there's a new structure of it. I do not explain this in detail, but if you are interested, there are a lot of pages who explain this very well. They built a more efficient layer structure, which may be a bit more complicated to understand if you know ROS1, but I think it will work better. The quality of service is a new concept of ROS2. And they maintain less non-robot specific code in their repositories, so it's easier to maintain, and the non-robot specific code is moved elsewhere and is maintained by other groups. Let's sketch out some points of the timeline of ROS2. The development started in 2015 with the first alpha version. From time to time, new features have been implemented, for example micro-ROS since 2018. Today, ROS2 is still in development phase with insignificant support. This situation might change in some years. Enjoying the full functionality, projects may move to ROS2 in 2025 or so, maybe later because it takes time and resources to migrate a project to a new platform. In the end, ROS2 is going to replace ROS1 one day. In my research, I found out that the European Union is kind of interested in supporting such projects. So ROS2, micro-ROS, and maybe some other robots-related software is being supported by the European Union. Let's take a closer look at micro-ROS. Do you know what's a microcontroller? It's everywhere and invisible. Microcontrollers are micro by computer power and memory. They often run on battery power, communicate over constrained networks or serial ports. There's no Ubuntu installed, just some crazy real-time operating system, RTOS. I forgot, they do what they are intended to do, and we want to run ROS on it because we need it. Microcontrollers are used in drones, sensors and actuators, things that a robot needs. or drones are even robots themselves. There's not enough memory given to run ROS in it. ROS 1 had serial to communicate with our microcontrollers. But in ROS 2 there's micro-ROS since 2018. That thing is some kind of middleware to put on top of your RTOS. Then you can run maybe one node on your device that can communicate with the other nodes, maybe on your laptop or on the robot or elsewhere. Micro-ROS does not need that much computation power. It mostly uses static memory instead of dynamically allocated one. You can tune it to consume even less resources, i.e. move some computations to other computers. Right now the following RTOSes are supported to be combined with micro-ROS. FreeRTOS, Sapphire and Natex. In experimental way there will be some more, I think. The European initiative Fahrverhalten supports the development of micro-ROS. I hope you are curious and want to learn more about ROS. There are some helpful pages where you can look at questions. So look at the ROS wiki or the ROS answers or where you want to look. At YouTube you will find some helpful tutorials on how to use ROS and its functions. Thanks for watching.